Hello, welcome back to another episode with Leetcode with Swift. Today we're going to be looking at generate parenthesis, which is the 22nd Leetcode question. It's quite interesting. Given an n pair of parentheses, so if n is equal to 4, we would have 4 pairs of parentheses that we have to work with or generate. Write a function to generate all combinations of well-formed parentheses. So well-formed parentheses. We'd explore that what a well-formed parenthesis is in a while, but let's look at the first example. So when n is equal to 3, we want output that has all of the combinations of well-formed 3 parentheses. So why is this well-formed? Because it doesn't have it doesn't initiate a closed bracket without checking if there has already been an open bracket. That's probably the case with all of these things. If you notice, there is never a closed bracket without an open bracket before it, right? So let's look at the second one. Second one pair would have a single parenthesis, and n is in between 1 and 8. That's our condition. Okay, so let's try out a brute force backtracking solution for this really quickly. So let's see when an n is 3. So we have to first identify the rules of backtracking, right? So when they say n is equal to 3, we already know that n it's basically means there are if this is an open parenthesis and this is a closed parenthesis, it basically means we have 3 of this and 3 of this in our inventory, and we have to generate an array of different combinations of these that have valid parenthesis closures. So our first rule is it has to be n open parentheses and n closed parentheses. And let's observe a little bit more. Let's try to build out different strings that we can make with n equal to 3, right? So it can we can start with open brackets and then close it, then do another open brackets, close brackets, another open brackets, close brackets, and this is still valid. Can we start with a closed bracket? Turns out we cannot because there is no open bracket for it, so it's not really enclosing anything. So that cannot work. Let's take a look at another example. We open a bracket, we open another bracket, and then we close it, and then we close it again. Then we open one more, and then when we close it. So at each point of us opening a new bracket, we have to check if number of open bracket is greater than number of closed brackets at that instance, and if it is that, then only then we can add a closed bracket, right? So so that means that our second rule should be closed parentheses are always less than open parentheses. I mean, at the point of insertion at least. And those are only two rules for now. We will see if there are any other rules that we have to follow. Let me erase this out and let me move this to the top. Okay. So let's assume we have a empty array, right? And we have to start populating it with whatever parentheses we're trying to update with our result value. Okay, so the output of this will be appended to result, and we would return that. So at every point we start with an empty array, and then we have to we start out with adding an open parenthesis. Okay, at this point we have two choices. We can either add, add another open parenthesis or just close this one immediately, right? Okay, so that's one of our solutions. Then if we continue this process, at every point we check if number of closed parentheses in the array is lesser than open parentheses, and only then we can add a new parenthesis. So for this one, we can either open another one, or we could choose to start closing parentheses, because number of closed parentheses right now is at this point it's 0 and open is 1. So this for this and this particular one only, so we can close this one since we chose to open it on this side. For the one on our right, we can either choose to open one like this, but we cannot choose to close one, right? Because the number of open parentheses is the same as number of closed parentheses at this point, which is 1 and 1 here, and that means we cannot have a left value here. So this is discarded. So if you see now, like if we go through multiple iterations of this, we can no longer add open parenthesis, because it's almost it's equal to n. So 1, 2, 3. These are three parentheses. So the only possible outcome from now on for this side is having a string that closes all of these open parentheses, right? Okay, so that's our first solution, because here closed is equal to open is equal to n, and then we would append it to the result here. Okay, let's continue on with the next one. If we see here, what we can do is we can either choose to close a parenthesis, or we could choose to open one. So let me actually rectify this, since we are always opening on the left side. Let me open one. So if I do this and I open one, and let's close it on this side, right? And let me take this here. Okay, on the left side we always open. Can we open one here? Yes, we can. So like this, open close, oh, sorry, open close, open open, right? And for this one, here it's both, here it's this one, we'll try to close that open parenthesis. So open close, that's it. Okay, so for this one, now we can notice that open is equal to 2, close is equal to 2, so there's only one possible solution from this path now. That's open close, open close, open close, the same result we saw earlier, right? So this also we would append to result. Okay, now so these three are now our contenders. So for this one possible scenario is open, open, close, open, and we choose to close this, or we can open it. Can we open it? Let's check. Number of open is 2, number of closed is 1, number of open is 3 again. So we can choose to open one here, but then we can see that our number of opens is bigger than 3 now. So this path is not possible. Okay, so the only single path for this is open, open, close, right? Okay, and from this point onwards, you can see that the only way we go out from here is open, open, close, open, close, open. So just matching these two brackets, and that's our third solution, right? So from this point now, um, open, open, close, close, open. Can we add a closed one here? I don't think so. So we would just simply close it with 2 iterations. This is the fourth solution. Now for this one, let's see, number of opens is 3. Okay, so that matches our end. So the only way it's going is open, close, open, open, close, close. And yeah, so these 5 are the solutions we'd add to a result. And that's what we would return ultimately for this solution. I hope that was clear. I know it's a lot of scrambling. I will try to explain it much better while I'm coding it, and I'll see you there. From the scratchpad, we saw that there are a couple of rules that we have to follow, and I'm going to be solving this recursively because that's the best way to do it and the most efficient way to do it. So for the rules here are so the recursion needs a base case. So we'll be appending the items you have found in the base case to the resultant variable. That's a array of strings, and we would the number two rule was if closed is less than open, only then we can add a closed parenthesis. And the third rule is that we saw it in the scratchpad but was not pointed out, was that if open is less than n, so think about it, if n is 3 and your open was 2, we could still add one more open parenthesis. So if open is less than n, only then we can add open parentheses. And these 3 are the basic rules that we have to follow for our backtracking solution. So let's jump in and initialize a variable called stack, which would hold all of the variables that all of the parentheses that will be appending for backtracking solution. So this would be of the type string, and a similar variable result that would house all of the resultant variables that we get from the backtracking solution. We will not be passing these two into the backtracking solution. This will be called what is called a global variable. Now, after this, we have to initialize a function. Let's call it backtracking, and let's give it a open integer that would carry open parentheses, current or open parentheses, which we would start out with 0 0, and then the closed one would be int also. This would also be called closed parentheses. Once we have started the function, the first thing we have to do is check the base case, right? So how do we check that? If open is equal to close is equal to n, then we have our result and we can append it to the stack, append it to the resultant variable and return, right? That's all of it. So if open is double equal to n, comma, closed double equal to n. Oh, sorry, I forgot. I called it close parentheses. Let's call it closed and open here, and open parentheses is equal to closed parentheses, and only then we would append something to the result. And now what's that something? There's an element here. So what we want to do is that we will look at the stack that we have currently, and we would try to join all those elements together into a particular string. Now we can do that with a map or a compact map in Swift, but I'll be using joined, which does pretty much the same thing of flattening array. So stack dot joined, and that's it. This would return us a string with all of our parentheses together, and we can append it to the resultant string, resultant array. Okay, now we covered the base case. Let's call it base case. Now, what are the cases that will drive the recursion, right? So these two will basically drive the recursion. Let's first address this one. Let's try to first add a parenthesis. So right off the bat, in the first call of backtracking, we won't have any parenthesis in the stack. So what that means is we can add one, right? So for the rules for adding a parenthesis was if open parentheses are less than n, then we can add one. So we would do stack dot append open parenthesis, oops, and then we would call the backtracking recursion function with our updated open parentheses. That means like whatever open parentheses we had in the previous call, we would just add one to it. So open parentheses plus one, and since we didn't add anything to the closed parentheses, it would remain the same. Okay, now once it returns, it has updated the resultant stack. That means, oh, I missed a return here. This is the place it would return. Once this hits, we want to remove this element that we just added, since we want to check if we can add a closed parentheses next. And having this in the stack means that we will already be accepting that particular character of open parentheses again into our stack, and that will lead to unnecessary random infinite loop recursion cases. So here we just want to remove the last element that we just added to the stack, and that's it. That's the first recursion case. Let's write the second one. It was simple. So if closed is less than closed parentheses is less than open parentheses, like we discussed here, we want to do almost the same thing. So let me just copy this and paste it here. But here we want to append a closed parenthesis. And since we added a closed parenthesis, we'll be adding 1 to this parameter and continuing the backtracking. And once that returns, we also want to remove this closed parenthesis, so we would pop it. And that's it. That's the recursion function to do this solution. What we can do now is, since we have the recursion solution, we can call it and initialized 0 open parentheses and 0 closed parentheses. Okay, so this would kick off the solution, and by the end of this line of code returning, we would have result here populated, so we can just simply return the result. Okay, that's the entire solution. Let's run it and see what happens. Okay, it runs. Let's run the example test cases. Okay, that runs too. Let's submit it. Awesome. That means it's pretty efficient, 72% of online submissions. Awesome. Okay, so that was the solution for generate parentheses. This is the first question in the recursion coding plan, text study plan. I'll be doing another 2 for recursion, and then I'll be moving to the week 2 of that coding plan. If you want me to keep continuing, give me a like and please subscribe. I'm hoping to get more videos out very soon. See you guys in the next one.